Good morning, students. In last class, we discussed about what are the various important features that we discussed in data integration. So simply we use a particular important concept called as chi-square test for for removing the what are the various redundancies data. Okay. So simply in every concept we have one particular scenarios. Those are first one is we have a cleaning data and we have a we have to understand a simple concept, that is, if you have a data from various repositories, so that in various repositories their data is should have a some noisy and incomplete. If the data is like that, we have to use one mechanism or one method in pre-processing, that is clean. If the data, second one is you are cleaning the data and storing the what we call as data warehouse, and second step is now you are combining. First one is checking the each and every database and cleaning the database. Now you have a 4 database with cleaning exact clean data. Second one is after completion of cleaning process, we have to store in data warehouse, so that you combining the 4 whatever you call as repositories storing in data warehouse. Now third one is, if you are storing in data warehouse, means data warehouse is one format and you retrieve the various repositories data in various formats. Now using a function mapping various repositories in a data warehouse, you are transforming various repositories data in a data warehouse format, so that the data should be in data warehouse format, transforming the integrated data into data warehouse format. Okay, a function. Now the data transformation main purpose is identifying a function that maps the entire set of values of a given attribute to a new set of replacement values, such that each old value can be identified with one of the new values method. Now you are taking data called as 45, 50, 60, 70 like that, but data warehouse format is in a decimal format. Now you have to use some function, identify exhibit that function in your data, so that it is replaced in data warehouse format. Okay, so that for this process you have a 1, 2, 3, 4, 5 mechanisms. So we have in data transformation we have 5 features. Smoothing is already we discussed in data cleaning. See, attribute feature construction, this will discuss in what we call as in next reduction concepts. And aggregation is already, you know, that we use some what we call as aggregation functions for grouping all the data and storing in particular data warehouse. And normalization, we will discuss this normalization in this data transformation. And we have another topic called discretization and generalization. This will discuss in that concept. Okay, so in this concept only we discuss only normalization. So cleaning we discussed 2 topics. Reduction we discussed chi-square, and data transformation you are discussing normalization. But see, if in exams if you ask data transformation, means you have to write all these 5 features. Okay, already you know about smoothing. You will in data reduction we discuss about attribute feature. Already you know about aggregations. You will discuss the normalization, the whatever feature construction and discretion. These 2 are will discuss in next topics. Okay, so for calculating normalization, that is mapping with a function from scaling to fall within a smaller or specified range, we use these 3 mechanisms called min-max normalization, Z-score normalization, and decimal scaling. These three are the important normalizations technique for transforming old data to new data. Okay, so why there is a need of normalization means, so you have to store particular different various what we call as various format data into specified format. Okay, so normalization, we already discussed that we have three features. First one is min max normalization. So it performs a linear transformation on original data. You have a old data set. If you are applying min max normalization means you are performing linear transformation on original data. Okay, suppose that we have a two values called as min a and max a. These are the minimum and maximum values of the attribute of a. Now you min max normalization maps a value vi of a to vi in the new range new of min a comma new max by computing. So this is the particular what we call as now this is the particular what we call as, I have a data. This is the function v dash is the value we are calculating, that is v is a variance, v minus min of a comma max a minus min a. Now you get a new max minus new min. New max minus new min is maximum value is 1.0. We have to specify the data 12,000 to 98,000 within a factor with 0.0 to 1.0. For example, you have an attribute. In that attribute, that is a salary attribute, minimum value is 12,000, maximum value is 98,000. Okay. In salary attribute, minimum value is minimum value is this one and maximum value is this one. Now you have to normalize the whatever the thousands data in 0.0 to 1.0. Clear? Now in the data, first of all is 73,000. Now you have to normalize this 73,000 in this particular range called 0.0 to 1.0, so that all the values will be transformed in, for example, this is a 1 2 3 4 5 values is 73. If there is a 1,000 value, if there is a 1 lakh value, so we have a three values with three decimals, four decimals and five decimals, or four positions, five positions and six positions. So these three are the different values means, now you are normalizing these three values into specified range value with 0.0 to 1.0, where 0.0 is a min value and 1.0 is a max value. Given in that attribute, we have a minimum value this one, maximum value is this one, calculated value is this one. So that, for example, this is the question and you are placing the original value v is 73,000 minus minimum of value is 12,000, maximum value is 98,000, minimum value is 12,000. We have a function with new max minus new. New max is 1.0 and new min is 0.0 plus new min value. New min value means 0. So that if we are calculating this value means you will get a value of 0.716. So that all the values which lays in 0.716. Okay. If you are calculating 1,000 means 1,000 minus 12,000 by 12,000 98,000 minus 12,000. So that we get a value. Okay. And the question is calculating by means of a Z-score normalization. Z-score is nothing but a zero mean normalization. The values for an attribute A are normalized based on mean. Now you have to calculate mean and standard deviation. If you are calculating mean and standard deviation means you will get a Z-score value. For example, you are calculating V dash as V minus mu A by sigma A. Suppose that the mean and standard deviation you are calculating mu minus sigma for the attribute income is 54,000 and 16,000. So with Z-score normalization, a value of 73,000 like this, V is a 73,000 and mu means what we call as mean. Mean of the value is 54,000. Standard deviation value is 60,000. So V minus mu by sigma. In some questions, they will give the data as for sorting data. So that based on equations like mean and standard deviation, we have to calculate, and you have to place in this equation. You have to place in this equation. So if they ask directly means you can place this equations. Conformly, they will ask a question. In pre-processing, they confirm one question will be comes. Third one is normalization by decimal scaling. So normalization means they are moving the decimal point of values of attribute. So already these two also you get a, this is a decimal value and this is value and this is also a decimal value. Okay, but it should be range in 0 to 1. The range is different here. Here the range will be different. Okay, based upon the value. So the number of decimal points moved depends on the maximum value of A. For example, V is a normalizer to V naught I by computing. If J is a small integer, it should be great less than 1. So for example, V is the actual value 10 power j. Suppose that V by 10 power j. Suppose that recorded values of A, now we are taking a value from two values called minus 986 to 917. We are assuming the value is 3 digits. So j equal to 3. So that minus 98 minus 986 by 10 power 3 means 10. Okay. Minus 986 by 1000 means you will get a 0.986. And 917 by 10 power 10 cube means you get a 0.917. So simple. This is so simple. Calculating under particular decimal value. So that note that normalization can change the original data quite a bit, especially the latter two methods shown above. Okay, we can easily, but this two is the important method. Change the original value. Whereas this is not changing the value. You are taking minus 98, 986 means there should be is minus 0.8. Only the data is different. Here the data is same with the normalization feature. Whatever taking 986, you are getting 986 means 0.986. 917 means 0.917. But you considering this the min-max normalization and normalization, you are taking the data as 73,000, but the getting data is 0.716. If you are taking 73,000 for jet score means you are getting the data 1.225. So both are contradict data. So that you can easily understand that if you take the normalization, if you use min-max and jet score, the data will be not a whatever you take in data. Whereas if you take a decimal scaling means the data is exactly same as the data. Okay, right. It is also necessary to save the normalization parameters such as the mean and standard deviation if using z-score normalization, so that future data can be normalized in a uniform manner. Okay, if you calculate a particular standard deviation and within set it one time, so all the attributes have same data means so that there should be no problem for calculation. Simply, if you ask another feature called as this is a simple feature called attribute construction, so that you are calculating, you are constructing new attributes from the given attributes and adding it in order to help improve the accuracy and understanding of structure in high dimensional data. For example, you may wish to add the attribute area. How you calculate area means based on the attributes called as height and weight. By combining attributes, attribute construction can discover missing information about the relationship between data attributes. That can be useful for a knowledge discovery. So you have attributes called as height and weight, but you are constructing a feature called as area. Based on these two attributes, you can easily calculate the attribute called as area. If there is some missed value means you have calculate by means of previous features by means of missing data, incomplete data and winning data. So this is the end of the transformation. In this transformation, we discussed only the normalization feature, and remaining data integration we'll discuss later. Thank you. Thank you all.